How well do you know the saturation multiverse? Not a question we commonly ask ourselves. My name's Luke. Welcome back to the Cognitive Whiteboard. We're here with Trax International today to talk about the multivariate uncertainty that goes into describing the saturation in three-dimensional space. Let's start with our petrophysicist, who, taking data measured in the well logs and correlating that against laboratory results done on the core, will construct some methods to derive the properties that we want to know about our field. None of which we're directly measuring, of course. Facies, porosity, permeability, saturation are all derived from other logs that are measuring physical aspects of the rock. Porosity is pretty good, but the others have got a significant amount of uncertainty on them. And yet, once derived, it's very common for us to see them thrown over the fence to the geologist as hard data. The geologist will then try to distribute that in three-dimensional space, perhaps with the support of some seismic properties. We will then model facies and porosity in 3D and take a great leap of faith to try to construct permeability. This is a vector field, of course, and we sometimes see people doing something as simple as using the core KV-KH ratios to try to represent some of that contrast, which isn't the best way to do it, by the way. Nevertheless, after that, it's thrown over the fence to our reservoir engineer, who, taking contact information and fluid data, will start to initialize saturation for the first time in three-dimensional space. The problem is, this is very detached from the derivations by the petrophysicist. When we look at comparing what's in the well logs to what's in the model at the cells intercepted by the wells, in the static properties, because they're distributed from those log data in three-dimensional space, obviously any value in the log is going to have a matching value in the model. That sounds sensible, it's what we should expect. But have you ever done that with saturation? If you take the saturation derived by this workflow, you will not see the same correlation. You will not have that 45-degree line. Why? Well, the assumptions that have been used in constructing this saturation model aren't the same and are not attached to the logs created by the petrophysicist. We need to repair that connection. So let's go back to where it's being derived from. How are we achieving saturation in the first place? Well, it's the buoyancy pressure created by the difference in the fluid densities and the height of the column pushing through the pore throats against a resistance of capillary pressure. The capillary pressure is a result of the cross-sectional area of the pore throats, the permeability, the interfacial tension, the strength of the interface between the two fluids, and the triple junction between the two fluids and the solid that we know of as wettability. All of those things together define how strong that resistance is by the capillary pressure. And finally, the total saturation takes into account the pore volume behind the pore throat, so different sizes and shapes of those pore volumes result in different saturations. This is why you see a need to have a different saturation for the same permeability in different rock types. If we bring all of this together and work as a team, we can actually solve this problem here and bring the saturation into a correlation with the well data. We do that by understanding that the M&M components in Archie's equation are uncertain and can be modified. We can understand that the permeability is uncertain and also can be modified. Likewise, contacts are rarely as simple as a single flat contact across the field, and we can adjust and modify the way that we're dealing with all of these parameters to bring these aligned together, and in doing so, actually explore new information in the field. What we find when we do this is that we often identify additional compartments in the reservoirs. We often end up with an improved permeability vector, and we end up with an understanding of reserves that's been unparalleled before. I'm proud to say we have a brand new course at Trax International that's teaching people how to do this. If you want to know, please drop me a note and we can get you connected. It's based upon the excellent work by Professor Dan O'Meara, who's been championing this approach for over 30 years. So if you'd like to know, please drop a note in the comments and we'll get back to you. But until then, I will see you back here at the Cognitive Whiteboard next time.